Hello children and welcome to your channel Sharda Educare, and in this video we will be learning area of trapezium and the practice set 15.3. Let's begin children. Here you can see a figure here, and this figure is the figure of a trapezium. And why do you say this figure is a trapezium? Because children, here we can see one line. There is another line which is parallel to the upper line. If I label it as A and this as B and this as C and this as D, then I can say that AB is parallel to DC. Okay? By looking at this figure, we can say that AB is parallel to DC. Then there is one more line here and there is another line over here. These two lines are not parallel. If I extend them further, somewhere they are going to cut each other. Yes or no? If I extend them, they are going to somewhere cut each other. Like see, if I am extending this line, if I am extending and this line, they are going to cut each other. So these two lines, that is AD and BC, are not parallel to one another, because if I extend them, they cut each other. So what you come to know here in this figure, we come to know that two line, that is AB is parallel to DC and AD is not parallel to BC, but it has four sides. AB is one side, BC is one side, DC is another side and AD is another side. That means there are four sides, and if there are four sides and out of four sides, two sides are parallel and other two sides are not parallel, then it is nothing but a trapezium. It is nothing but a trapezium. Now here what we are going to do, we are going to find the formula for the area of trapezium. Okay. Now there is, let's begin with how to do it. Let me draw a line which is perpendicular to DC. There is one more line which is perpendicular to DC. Clear? Now this line perpendicular to DC and this line perpendicular to DC we have drawn. Fine. This is nothing but height of the trapezium. So let me label this point as M and this point as N. So what we could say, we can say that AM is perpendicular. This sign is a perpendicular sign, children. This sign is a perpendicular sign. AM is perpendicular to DC. Okay, and BN, this is BN. BN is perpendicular to DC. And why? Because we have done construction. We have drawn construction, we have done like this, and therefore they are perpendicular. Is that clear? So in this figure you understood AB is parallel to DC, AM is perpendicular to DC, BN is also perpendicular to DC. Is that clear? Okay. Now what we will do, we are going to find out area of this figure. This figure is a figure which can be called as a triangle. Clear? So let me find area of triangle. Area of triangle AMD. AMD. Children, what can you say about the area of triangle AMD? I think you can say that half into base into height, isn't it? We have learned it. Now half into, what is the base? DM into height. Let us take H as height. Okay. So this is area of triangle AMD. Fine. Now let's find the area of this figure. Area of triangle BNC is again half into base into height. Here will come into, okay. What is base? Base is nothing but NC. NC into height. This is the height, H. Okay. Now see children, AM is equal to BN. I can write here AM is equal to BN. And why? Because height of the trapezium, that can be equal to one another, because the height of the trapezium AB is parallel to DC. So height will be between A, B, all the point will have equal length. Therefore, we can say AM is equal to AN. Okay. Why AM is equal to AN? Because AB is parallel to DC and the perpendicular height between the two parallel lines will be same. Clear? Now, if I want to find out area of quadrilateral A, B, N, M, MN, it will be how much? It will be length into breadth. It will be length into breadth. Now see, this is perpendicular, this is perpendicular. So this line AM is parallel to BN and already AB is parallel to DC. So it will be parallel to MN. So it will be a parallelogram. If it is a parallelogram, it can be a rhombus, it can be a square, but if it can be a rectangle. If each angle is 90 degree, then it can be a rectangle or it can be a square. Okay, I can say here, see, length into breadth, and we can say that AB is parallel to DC, given, already given, opposite sides are parallel. AM is parallel to BN, we have done the construction. Clear? But this AM is perpendicular to DC, also BN is perpendicular to DC. Again we have done the construction. So therefore we can say quadrilateral ABMN is a parallelogram because opposite sides are parallel. Okay, but each angle is 90 degree and therefore we can use this formula, length into breadth. Okay, so now what I will do, I'll find out area of this. Area of quadrilateral ABMN ABMN is equal to length. ABMN length is how much? AB, and breadth is how much? BN. Clear? Now if I want to find out the area of this figure trapezium, what will I do? I'll write area of trapezium. Now which trapezium? ABCD. Okay, ABCD is equal to area of triangle ADM plus area of quadrilateral. Which quadrilateral? ABMN let me write here, plus area of quadrilateral ABMN plus area of triangle BNC. Now if I write the values, area of triangle ADM, that is AMD, half into DM into H, half is equal to area of ADM or AMD is half into DM into H, half into DM into H plus area of ABMN is what? AB into BN, AB into BN, BN is nothing but H plus area of triangle BNC is half into BNC is half into NC into H, NC into H. Now look at this, children, this has upon 2, here also there is upon 2, but in this there is no upon 2. So what will we do, you know, we will introduce here upon 2 as well, we will multiply it by 2, okay, by 2. So the value will remain same. Now this is also upon 2, this entire is upon 2, this also is upon 2. So we can add them. Clear? So if I am adding, what is happening? Area of trapezium, which is that trapezium? ABCD is equal to half is here, H is here, half is here, H is here, half is here, H is here. So I can take that half H very clearly out. What will be left inside? From here I have taken half as well as H out. So what is left? DM now what is there? Plus. Now from here I have taken half, this half and this H out. So what is left? 2 times AB. Then from here this half and this H is out. So what is left? NC plus NC. Okay. Half H I wrote. DM. Where is DM? This is DM. plus 2 times AB. Now AB is equal to Mn. AB is equal to Mn. We have first only proved that opposite side of parallelogram are equal. Opposite side of parallelogram are equal. Okay. So dm plus 2 times AB. 2 times AB means I can write down AB plus AB 2 times na plus NC. Clear? Now here half H dm is this and AB is equal to Mn. So this AB I can write down as Mn because AB and Mn are equal. So in place of AB I am writing Mn plus AB plus NC, that. Bracket close. Now look at this, children. Half H, okay, dm where is dm? Dm, okay, plus Mn plus NC, leave this, okay, plus NC. Where I am stopping? I am stopping at C, that means DC. Clear? Total it becomes to DC. So I can say here dm plus AB plus NC is nothing but DC. So dm is gone, Mn is gone, NC is gone. See, dm, Mn and NC is total DC. Now left is what? The left one is AB. So I can say here plus AB. Clear? Now what you are getting here? Half into H DC plus AB. DC plus AB is nothing but sum of parallel side. These are nothing but parallel side. AB is parallel to DC, and what we got? Sum of these two parallel side. So what final answer we are getting? Area of trapezium. The final answer we are getting of area of trapezium is half into sum of parallel side into height of trapezium. So this is the formula for area of trapezium. Children, you can learn very easily. It's very simple, it's not very difficult. First of all, you have to understand what the figure is. The figure is a trapezium. Why it is a trapezium? Because opposite sides are parallel. And here I have drawn AM perpendicular to DC, BN perpendicular to DC. Okay. Now what is happening? These two sides are parallel, these two sides are not parallel. So we will find out the area of triangle, area of this triangle, and in the middle area of this quadrilateral, and we will add all these area. When we add all these area, we will be getting the area of trapezium. Clear? and then you place the values and you get final answer. Area of trapezium is half into sum of the parallel side into height of the trapezium. Now let us move to the next question, children, which is solved example from your textbook. In a trapezium, this is the figure of a trapezium. Okay, two sides are parallel. If the distance between the parallel side is 6 centimeter, this is the distance between the two parallel side, and that is 6 centimeter, and length of the parallel sides are 7 and 8. Now this side is AB and this side is DC. Which is bigger one? DC is bigger one. So length of the parallel side is told. Length of the parallel side is 8 centimeter and 7 centimeter. Now here which are the two parallel sides? AB and DC are the two parallel sides. So 7 can be this and 8 can be this. Okay. Find the area of the trapezium. Now only we have learned area of trapezium. Area of trapezium is equal to half into sum of parallel side into height. This is the height. Okay. So let's take half into sum means plus of which sides? Parallel side. So AB is the parallel side to DC, sum of them, into what? Into height. Height is how much? 6 centimeter. Let me write first the value of height. Height is AM. AM. Now place the value, that is half into AB is how much? 7 plus DC is how much? 8 into height is how much? 6. Now first we are going to add 7 centimeter and 8 centimeter. 7, 7, 14 plus 1, 15. 15 centimeter into height is what? 6 centimeter. 2 ones are 2 threes are. Now 15 into 3, that would be 15 threes are 45, and this is centimeter and this is centimeter, which will be centimeter square. Now in this sum, children, I am giving you to learn the table of 15. Clear? 15 ones are 15, 15 twos are 30. Write down the table and learn the table. So if you learn the table, so many calculations become very easy. So area of the trapezium is equal to, final answer when you are writing, you will be writing like this. Area of trapezium is equal to 45 centimeter square, and create a box around it. Let's move to the second question, children, now. Second example. There is only one example, sorry. Practice set 15 point. You can see here one figure and it is AB. Clear? This is DC. This is BC or CB, and this figure is AD. AD is perpendicular to DC. Okay. A, D, C, B. What we need to do? In quadrilateral ABCD, A, B, C, D, okay. Length AB is 13 centimeter. So this one is given 13 centimeter. AB is given 13 centimeter. DC is 9 centimeter. This is 9 centimeter. And length AD is 8 centimeter. AD is 8 centimeter. Find out the area of the quadrilateral ABCD. Now, if you look at the figure ABCD, it appears to be a trapezium. Now, why it is a trapezium? AB is parallel to DC and AD is the height. So, we can apply the area of the trapezium here. So, how we can do it? Area of A, B, C, D is equal to half into AB plus DC into AD. AD is the perpendicular height, so we will be using AD as height. Let us place the value. Half into AB is how much? 13. DC is how much? 9. Into AD is 8 centimeter, children. This is centimeter, this is also centimeter. So, half into 13 and 9 how much? 13 and 7 would be 20 and then more to 22 centimeter. Okay. Into 8. Now, divide 2 ones are 2 11s are 11 centimeter. So, what you get? 11 centimeter into 8 centimeter is equal to 80, 11 8s are 88 centimeter. Okay. So, finally, area of ABCD is equal to 88 centimeter square. Put a box around it. And why did we use this formula? Because AB is parallel to DC. So, and AD is the height. So, we can use the trapezium formula. Let's move to the next question, children. Length of the two parallel sides of a trapezium are 8.5 and 11.5 centimeter. Here the figure is not given, but we can draw the figure. Okay. Length of the two parallel sides. This is one side and this is another side. And if I want it to be a parallelogram, a trapezium, then join this and join this. It becomes what? A trapezium. Okay. So, length of the two parallel sides of a trapezium are 8.5 and 11.5. So, this will be 8.5 and this will be 11.5 centimeter. Clear? And its height is 4.2. So, height will be measured from here and that is given 4.2 centimeter. Find its area. Again, two parallel sides are there and one height is there. So, area of trapezium is equal to half into sum of the two parallel side, that is 8.5 plus 11.5, 8.5 centimeter plus 11.5 centimeter into height. Height is how much? 4.2 centimeter. So, this will be equal to half into, we have to add them. Now, how to add? See, children, 8.5 I have to add with 11, see 0.5, point below will come point and 5 will come up and here will come 11 and then you can add 5 plus 5 10, carry 1 8 9 10, carry 1 20. So, it will be, if you add 20, 0.0 afterward you do not have to count. Next, into 4.2. Now, I can divide 2 ones are and 2 tens are. So, what am I getting? I am getting 10 into 4.2. Now I can directly also multiply 10 2s are 20, carry 2, 10 4s are 40, 40 plus 2, 42, and here decimal after one digit, so here decimal. Centimeter. This will be centimeter. This is centimeter. So it will be centimeter square. So area of the trapezium is 42 centimeter square. Final answer will be written like this. Area of trapezium is equal to 42 centimeter square, and create a box around it. Let us move to the next question, children. Third question, PQRS is an isosceles trapezium. In a trapezium, two sides are parallel. Here they have told isosceles trapezium. Isosceles means two sides are equal. Okay? Means which two sides are equal? This is one side and this is another side, which are parallel to one another. And isosceles means two sides are equal. So which are those two sides which are equal? The one I am marking with green and the another which I am marking with green. These two are equal to one another, and therefore that is the reason we call it as isosceles trapezium. So this one is an isosceles trapezium, and length PQRS it is PQRS. Length PQ is 7 centimeter. Segment PM is perpendicular to SR, and segment SM is equal to 3 centimeters. So this is 3. Clear? Distance between the two parallel side is 4. This is the parallel side and this is the parallel side. Distance between them is 4. So which line is going to be 4? This one will be 4. Okay. Find the area of the PQRS. Now here, length of the two parallel side, out of that only one parallel side is given. Height is also given, but another parallel side is not given. But we can, with the parameter which are given, we can find out the SR. Clear? Now here see, PMS. In triangle PMS, angle M is equal to 90 degree. And why? It is given. No? Why it is given? Because PM is perpendicular to SR. Therefore, by Pythagoras theorem, PS square is equal to SM square plus PM square. SM is 3 square plus PM is 4 square, which is equal to 9. 3 square is 9 plus 16, which is equal to 9 plus 16 is 16 plus 4, 20, 25. So PS square is equal to 25. So we can write again PS square is equal to 25. If I remove this square, then I will have to place the square root on the other side. So what will I get? PS is equal to under the root 5 into 5. And children, you know, if any number is inside the root 2 times, then it will come out of the root 1 time. So, I will get PS is equal to 5 centimeter, and we will be getting PS as 5 centimeter. Now, we got PS 5 centimeter, and we know PS is equal to QR, first only we discussed. So, we can write QR as 5 centimeter. And if you go to see PQ, children, if you go to see PQ, this which I am tracing is nothing but a quadrilateral, a parallelogram. If this is 90, this is also going to be 90. This is 90 given in the figure. I can draw a perpendicular, not given, I can draw QN perpendicular. So, QN is perpendicular to SR construction. Okay? If QN is perpendicular to SR, PM is equal to QN, opposite side of parallelogram are equal, opposite sides of parallelogram are equal. So, if this is 4, this also will be 4. Clear? Now, what will happen? This is 5, this is 4, it is a right angle triangle. I can again use Pythagoras theorem in this. No need of Pythagoras. This is 5, this is 5, this is 4, this is 4, and if this is 3, this also will be 3, isn't it? So, I can say NR is 3. Got? So, therefore, NR is equal to 3 centimeter, because see, this triangle is equal to this triangle. Yes, if this side is 5, this side is 5, this side is 4, this side is 4, this is 90, this is 90. If this is 3, this also will be 3. Clear? Okay. So, PQ is equal to MN is equal to 7 centimeter, opposite side of parallelogram. So, children, we got SM3, MN7, NR3. So, what can I say here? I can say that SM plus MN plus NR is equal to, SM is how much? 3 plus 7 plus 3 is equal to 7 plus 3, 10, 10 plus 3, 13 centimeter. So, finally, we got SR. SR is 13. PQ is 7, SR is 13, and height is there. Can we find out area of this figure? Yes, it is a trapezium. We can easily find out. Therefore, area of quadrilateral PQRS is equal to half into PQ plus SR into height, that is PM. Place the value half into PQ is how much? 7 plus SR is how much? 13 into height is how much? 4. All are centimeter. So, right here centimeter, centimeter, centimeter. Now, what you are getting? Half into 13 plus 7, 20 centimeter into 4. 2 tens are 10 fours are 40 centimeter. So, 40 centimeter square. So, we can say finally that area of trapezium is 40 centimeter square. Children, we have done with the exercise 15.3. Learn the tables, all the tables which we have used here. See, if you don't know the table, you write down, add the numbers one after the other and you get the table. Learn the table, table will help you to do the calculation, plus practice these sums, and like my videos, share my videos and subscribe my channel if you have not subscribed. Thank you children for watching my videos.